Hi, everybody. Hey, everybody. We're at the 2-6 to 2. No, I'm sorry.
No.
Let me take that back. 2-7 to 2-9 quiz prep in your binder. Page number. It's going to be about number 65. I'm going to guess. Fricky?
Survey says not even close. The quiz prep.
Quiz prep.
I don't know.
Very end.
73, 74, 75.
73, 74, and 75. Bonus page for you today. Yes. Okay. We're graphing equations, writing equations, finding slope, all this good stuff that you enjoy doing, that Mr. Fricky has taught his class wonderfully, and I've tried my best. Okay. Let's graph the equation. Y equals 4.5. Y equals 4.5 x. That looks like a proportional equation written in the form y equals m times x.
That's right.
This is your slope, and there is no y-intercept because that y-intercept is 0. Yes, 0, 0. So first point at 0, this is my slope. Remember, 4.5 over 1. Rise, run. I know it's hard to see, but we're going to go up 4.5 units over 1 unit. Up 4.5 over to 1. Draw your line through those 2 points. You just graph that equation. Thank you. Thank you.
Nice job.
Let's go to question number
Abigail.
2. Oh, my friend Abigail. Hey, looks like Abigail. The graph shows how many apples Abigail can pick if she maintains a constant rate. What is the linear equation for this relationship? How many apples can she pick per hour? Wow. Linear equation. That means I'm going to have to write something in the form of y equals mx plus b. Looks like I need to find a slope. Find 2 points. If 0, 0's there, let's use it.
Don't be a hero.
Okay? Let's use this point, which is the point 2, 30. Okay? That's also a dentist's favorite time, 2:30.
Yeah.
Okay, find the slope. Y minus y, 30 minus 0, x minus x, 2 minus 0, 30 over 2.
15.
That's 15, my friends. Now, is there a y-intercept? Well, there is.
Yes.
Technically, it's 0. This is a proportional relationship. So, writing this linear equation, this is my slope. That's what's going in there is the coefficient of x. Abigail can pick this many apples per hour.
1.
Well,
2.
no.
She's not a very fast apple picker.
Okay, she can pick 15 apples per hour. Remember, folks, we call this our constant proportionality, our unit rate. It's telling us how many she can pick per hour.
Slope.
Okay, number 3, a recipe requires 2 cups of milk for every 5 cups of flour. Write an equation to represent this situation. Well, this sure looks like a ratio.
Ratio, people.
Comparing milk to flour. We can write that as a fraction. 2 things of milk, 5 things of flour. That's your ratio. That's your slope. That's your rise over run. All that good stuff to write the equation. You take that and you put it right into that equation. Y equals 2/5 times x.
Yep.
There's no y-intercept. Why not? Because if you don't add any milk, how much flour do you need? That's right, none. None. Okay, moving on. Gosh, this is good stuff. Ooh, a table. A table. Oh no, a table. Suppose you were given this table. How would you write the equation of the graph of this relationship? Which statements are true? Ooh, select all that apply. Well, is the ratio of y to x the slope? Well, let's find out. Y to x. X value, y value. Now, that just means take 3 divided by 2. I took a y value divided by, that's 1.5. 6 divided by 4, well, that's 1.5. 9 divided by 6, anybody want to guess?
1.5.
1.5. Boy, it looks like these are all coming out to be the same, which means, yes, we can take y divided by x. That is our slope. Now, if we take y divided by x, we get 1.5. Would this be the correct equation? Y equals 0.767x? No. Nope. Not choosing that one. The ratio of x to y is the slope.
Nope.
No. We just said over here the ratio of y to x is the slope. It can't be both. Letter D, the equation is 1.5x. Yes, go for that one, folks. A and D. Questions?
Nope, they're quiet.
Hey, number 5. What is always true about a line that slants upward from left to right? Ooh, another select all that apply. I love these.
I think they're great too.
Well, if they go up from left to right, is the line positive?
I don't know. Could you draw me an example? So maybe maybe I'm a visual person, Mr. Knoll.
Okay,
So I need a line that goes up from left to right.
something like that.
Oh, okay.
Yeah, that's positive. That's what we've talked about and said. That's a positive slope. Well, as the value of one variable increases, the value of the other variable increases. Well, we've talked about that as well. X value, Y value. Well, as the X value increases, the Y value also increases.
Also, yes.
Sweet. A and B. Maybe it's going to be all of them.
Maybe.
The slope of the line is a fraction. Well, it could be.
But it's not always.
But is it always a fraction? No. Letter D, the graph of a line has extremely small values. Well, again, could have small values.
Not always.
But not always. A and B. Sweet. Moving on. Number 6. Ooh. Oh, yes, these are my favorite. What is the y-intercept? Well, this line crosses this line right there at 0.
0.
Yep. 0. There it is. Oh, this graph shows the rate of a miner's ascent. That means the miner's going up to the surface. What does the y-intercept of the graph represent? Well, the y-intercept right there is -3. Okay, there's your y-axis. Here's the line. They intersect at -3. What does that mean about the miner?
Going up.
He started 3. Ooh, we don't have a label over here. Let's just,
Meters?
3, we'll say meters.
Kilometers?
Below
Earth.
the surface.
Earth.
Okay? So it's a y-intercept of -3, which means he's starting 3 units below the surface, or in this case, 3 units below the origin. We can say anything. All right, moving on, number 8. Mr. Frankie, have I said folks yet?
No, but you should.
Okay, folks, number 8. Which statement or could describe the graph of a non-proportional relationship?
Ooh.
Yes, another select all that apply. Well, is the y-intercept negative? Well, if it's non-proportional, that means it doesn't go in through the origin. So that means it could be negative. Could it be 0? No. The line intersects at the origin? No. Could the y-intercept be positive?
Potentially.
Yeah, could be. A and D. All right, number 9 just says draw a line that has a y-intercept of -2. Well, that just means make a point at -2 and draw a line through it.
Any line.
That line would work. Okay? This line would work. Hey, folks, how about this line?
Folks,
how about... Oh, get off there. This line. Any of those lines goes through -2. That would work. That was not a hard one.
I was confused.
Oh, Jilly.
Jilly
earns $15 per week for mowing the lawn and
Man.
deposits the money into her savings account. The amount of money in Jilly's account can be represented by this equation. Y equals 15x plus 250, where x is the number of weeks she has been mowing the lawn. What does the y-intercept? Well, what is the y-intercept? Is this the y-intercept?
No.
No, that's your slope. Remember, y equals mx plus b. This is your y-intercept. Well, it doesn't ask you what it is. but I'll tell you it's $250. Now, what does that mean about Jilly's bank account? She starts with how much money?
$15.
No,
No?
that's the slope.
Oh.
We want the y-intercept. She starts with $250.
Man, it's good to be Jilly.
Yeah, good for her. Henry was good.
Thanks, Henri.
Thanks, Henry. All right, here we go. Write an equation in slope-intercept form. Well, if I see slope-intercept form, it better be thinking y equals mx plus b. I'm going to start with the easy one. Slope, y-intercept. I'll start with the y-intercept. Right there. 2. Can you see that?
Yeah. Ding,
Good.
ding, 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 ding.
Okay, now I need to find another point somewhere on that line. I think I'll use this point, which is the point 2, -2. So we have the point 0, 2, and we have the point 2, -2. Now again, folks, these are not the only 2 points you could use. It's just 2 points I'm choosing. Well, y minus y, x value, y value, x value, y value. Start with the big one, subtract the small one. So let's go with 2 minus -2. On the bottom, if I started with this 2, I got to start with this on the bottom. So 0 minus 2. Well, 2 minus a -2 is 4. 0 minus 2 is -2. Last time I checked, 4 divided by -2 is
-2.
-2. So I have my y-intercept, I have my slope, put it into equation.
Put it all
form.
together, folks.
Y equals blank x plus blank. What's going here? Slope. Well, what's my slope?
-2.
So -2x plus my y-intercept.
Blank.
Which is 2. All right. Can we move on to the next one? Yes, we can. Number 12. Yes, we get to do it again.
Ding, 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 ding.
Find the slope, find the y-intercept, write the equation. Well, let's start with, on this graph, I know it's hard for you guys to see. Look at your paper, y-intercept -4. Now I need to find a second point on that line. I'm going to go up here to this point, which is the point 2, 2. So we have the point 0, -4, and
Ba-bam.
2, 2. Yes. All right. Y
2
minus
tooths.
y. X, y. X, y. Big one minus the small one. Well, is -4 bigger than 2? No.
Oh, yeah.
2 minus a -4. Okay? 2 minus a -4. On the bottom, should I do 0 minus 2?
Nope.
No. If I went 2 minus -4, I got to go 2 minus 0 on the bottom. Well, 2 minus -4, that's 6. 2 minus 0 is 2. 6 divided by 2
3.
is 3. There we got our 2 values. Sweet. Y equals blank x plus blank. Well, slope, 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 slope. Ooh, I'm going to change this plus. Is that okay, Mr. Fricky?
Yeah.
To -4.
That
You like
works.
that?
Or you could have put plus -4, but it's probably more better if you put -4.
More better, definitely. Y equals 3x minus 4. 13, tickets to a hockey game. Ask Mr. Fricky about playing hockey. One of the greatest of all time in the state of Indiana.
That's right.
Of all time. Tickets to a hockey game cost $34 each, and the parking costs $20. What is the equation of the line? Well, folks, we've got to think. Is this our slope? Or is this our y-intercept? Well, it's $34 each. So every time I buy another ticket, it costs me $34 more. That sounds like a rate of change. Well, let's think about parking. How many times do I have to pay parking? I got to park my car one time, right? Do I have to pay another parking fee?
No.
No. So this is my rate of change. This is my slope. This is my M value. This is going to be your B value. Remember, even if you don't buy any tickets, guess what? You got to pay for parking. So it's going to cost you $20 even though you're buying 0 tickets. That stinks. Oh well.
Might as well buy some tickets then.
Might as well buy some tickets. Put it in equation form. Y equals, put your slope here, 34x plus your y-intercept. 34x plus 20. Questions?
They're quiet today, Mr. Knoll.
They are very quiet today. We only got 2 left. We only have 2 left. Graph this equation. Y equals negative 2/3 x minus 3. This is your slope. This is your y-intercept.
B.
Where should I make my first point?
2/3. Negative
Your first
2/3.
point at the y-intercept,
Oh.
negative 3. Make a point. Now, we need a slope of negative 2/3. Am I going to start at the origin? No. This is your initial value. This is your starting point. We need to give a slope of negative 2/3, which again are rise, negative 2, or run a positive 3. So from this point, not from the origin, from this point, rise a negative 2. Up to?
Down 2.
No, a rise of negative 2 means go down 2, a run of 3, 1,
Run right.
2, 3. Always run to the right. Okay, we've got our 2 points. Draw your line through those 2 points. We've graphed that equation.
Nice job.
I think I'm 14 for 14 so far.
Mm-hmm.
So let's see if I can get the last one right. Which equation is not, keyword, not written in slope-intercept form? Well, slope-intercept form, y equals. That's slope-intercept form. So basically, I'm looking for something, y equals. If it don't say y equals, it ain't in slope-intercept form. Does this say y equals?
Yes.
Does this say y equals?
Yes.
Does this say y equals?
No.
Does this say y equals?
Yes.
Where did he say no?
Yes. Yes. No.
Boom, that one's not in slope-intercept form. Okay, so folks, if you checked your work there, you should be ready for your 2.7 to 2.9 quiz. Good luck to you. Do well. Make Mr. Knoll proud. Make Mr. Freaky happy, which is not easy to do.
Mm-mm.